Hey, greetings, Jeff friends, and welcome to my YouTube channel. And please, this is a question from the Cambridge 2013 Step 1, and this is their question number 4, if I'm not mistaken. This is their question number 4, and it's on integrations, and particularly, it's on reduction formulae. And the question says that we should show that for n greater than 0, the definite integral from 0 to pi over 4 of tan nx sec squared x dx is equal to 1 over n plus 1. Now we know for sure that when it comes to integrals, tangent and secant are best friends in integrals, and since I have tan and I have sec squared x, that makes the word so easy for me, such that I can say that implies that the integral from 0 to pi over 4, let me copy out the equation, of tangents of nx sec squared of x dx is sec squared of x dx. That implies, because I can now take a nice u sub. In this case, I can let my u equal to tangent x, such that I now go ahead now to differentiate, such that I have du is equal to what? Sec squared of x dx. Now my du is the same as what? Sec squared of x dx, right? Now, but what if I still look in the equation, I'll see that I have sec squared x dx, and according to my derivative here, it is my du. That means that this integral is now going to turn out to be, now the integral from, I'll change the limits now. These are my x values. When x is 0, I plug in 0 here, I'll see that u will be going from 0. If x is pi over 2, what is tan pi over 2? Is obviously 1. Yes, therefore means I'm going to have now the integral from 0 to 1 of tan x. What is tan x? Is u. Therefore it's going to be u to the power n because of this one. Then sec square x dx now is my du in this case. So now that implies, and I want to integrate, since I need to integrate u to the power n in the u world, therefore I can just do the reverse power rule. So I'm just going to add 1 to the power, and divide that by the new power, n plus 1. That I'm going to have 1 over n plus 1 into u to the power n plus 1, and the limits of integration are from 0 to 1. So I'm just going to plug in 1 to 0. That implies I'm going to plug in 1 to 0. That therefore implies I'm going to have, if I plug in 1 here, I'm going to have 1 over n plus 1 into 1 to the power n plus 1 minus 0. That's, I'm going to put this 0 into this u, and if you put 0 here, everything dies down to 0. So minus a big 0. That just gives me 1 over n plus 1 as my answer, as required. Yes, as required. So this is just a proof. That's just it, as required. And a proof needs a conclusion, so you just say 1 over n plus 1 as required. Yes, that's going to be a very, very great one. So thank you, ladies and gentlemen, for watching, and see you in the next video.